Okay, we're looking at a demonstrator here where we're going to simulate the action which takes place inside a typical air conditioning or refrigeration system. And the clear tubing is simulating the copper tubing in the system. And we've got, of course, initially to start the demonstration, a competitive block type dryer here to show the ability of this dryer to filter out solid contamination. We've also got a clear plastic beaker here, and that's simulating a system receiver. We've got it filled with a low pressure refrigerant called Vertrel, and a pump inside of this beaker which is going to move the Vertrel through the system, and it is simulating a compressor in the system. I'm going to start the system and notice the refrigerant moving through the dryer and through the tubing and back through the circuit. After we operate it for a second or two, I'm going to add some system contamination. This happens to be silicon carbide grit in approximately a 20 micron particle size. A dryer must be able to remove this particle size in order to protect the compressor bearings from wear caused by solid contamination getting into the bearings. So we're going to start the system and run it, and then add the contamination to the system. And I want you to be alert to the dirty refrigerant going into the dryer and how clean it's coming out. And after I run that for a minute or two, I'm going to simulate system vibration by tapping on the dryer, and then I'm going to cycle the system on and off, which you would normally see in a system because the thermostat contacts are satisfied and shut down the system. So I'm going to start up the system and just run it here, and you can see the refrigerant going through the system. And now I'm going to add the silicon carbide grit simulating system contamination. And again, a dryer must remove this contamination to protect the bearings in the compressor from wear caused by the solid contamination. Notice how dirty the beaker is becoming and the dirtiness of the refrigerant going into the dryer and how clean it is coming out. The system is still quite dirty, and for a dryer to do a good job, it must be able to hold on to the contamination in the presence of system vibration. Because all systems do have vibration, I'm going to simulate that vibration by tapping on the dryer and then be alert to the outlet of the dryer and the clear copper tubing to see if any contamination comes out when I tap on it. Notice how it darkens, how the Vertrel, the clear Vertrel gets dark. That's the contamination releasing as I tap on the dryer. Now, supposing that the thermostat contacts are satisfied at this point and we want to shut the system off, as any system will. So we're going to cycle it off, and when we cycle off the system, what's happening inside the dryer, this happens to be the competitive block type dryer, the liquid level drops, and as the liquid level drops, it takes the contamination down to the bottom and it bypasses the block. So this design dryer is unable to filter out the contamination on the system cycles. So be alert when I turn it on, be alert to the outlet of the tubing, the clear tubing here, to see if we get a big residue being released from the block. Notice that this big glob of contamination, a block style dryer is unable to hold on to the contamination that it initially picked up. And I'm going to do that again so that you can get a good look at it. Pay attention to the outlet of the dryer and the clear copper tubing, or the clear tubing going into the reservoir. I'm cycling it off, and this is simulating the thermostat contacts are satisfied. The system is in the off cycle now. Liquid level is dropping, and the contamination is being lowered, so it's able to bypass the filtration effect of a block. That's not going to happen when you see the Emerson Flow Controls dryer installed, because our patented filtration system ensures that that's not able to happen. Here, the thermostat contacts again are now going to make contact when we start the system, and once again we get a big glob of contamination moving through the system. Notice too, the receiver here is still quite dark, and so there's a lot of contamination left in the system. We're going to shut off the system now and change the dryer over to see how the Emerson dryer is able to perform under the same type of test. Okay, we have now removed the Sporlan block type dryer from the demonstrator and installed the Emerson EK filter dryer into our system. And notice that, first of all, in the receiver that the block type dryer was unable to remove all the contamination from the system. So in spite of that, we've installed the EK dryer, the Emerson EK dryer, and even though that the refrigerant is not totally clean, we're going to add another full scoop of contamination to the system. And this contamination is in the 20 micron particle size, which if this contamination is allowed to flow through the system, it will get into the bearings of the compressor and foul out the compressor bearings and cause wear and ultimate a compressor burn. So notice the contamination going into the dryer and how clean it is coming out. And I'm going to simulate compressor or system vibration here by tamping on the dryer itself. So notice the outlet of the dryer and the clear tubing, and notice that there's just bubbles coming out, no contamination as there was with the previous dryer. So it's holding on to the contamination that it picks up. Now, I'm also going to demonstrate the cycling on and off as you would see in a typical system. When the thermostat contacts are satisfied, the system will shut off. Now on the competitive block, as in our dryer as well, the liquid level is dropping, and with our EK dryer, the contamination is not able to bypass the filtration system. So when we turn the system back on, simulating that the next call for cooling, you're only going to see bubbles coming out. You will not see any contamination because all of the contamination in the system is being picked up and held by the dryer in the presence of both vibration and system cycling, which you will see in any normal system. Now, if you will, notice the receiver portion here, how it's cleaning up quite nicely and picking up the contamination, and we'll just see how quickly we can remove this contamination from the system, because the quicker we remove it, the more protection we're giving to the various components, particularly the compressor and the bearings internally in the compressor. Notice how the copper tubing or the clear tubing, you can start to see that inside of the beaker of Vertrel, and it's cleaning up and picking up even the very small particle sizes. Ours, the EK dryer picks up a 20 micron size, and which you will find loose in a system. Our dryer tends to plug up faster because it's got a dual filtration system. But that's not a bad thing, that's actually good, because we're providing more protection quicker than any block style dryer can. Plus, once it picks it up, it holds on to it and will not release it, even in the presence of vibration or system cycling. There, notice how clean it's getting now. It's almost as though I hadn't added any contamination to the system at all. So this ensures that only clean refrigerant and oil is going to be pumped through the system and through the compressor. So the next time that you're needing to buy liquid line dryers, be sure to remember this demonstration and the Emerson EK dryer, which removes 40% more contamination than any block style dryer can. And not only does it remove it, but it holds on to it in the presence of all of the system problems that are going to arise. Once again, notice the cleanliness of the refrigerant at this point, and the dryer has certainly done a good job in cleaning up the system and providing maximum compressor protection.